Okay, we'll finish 2-2 today. Yesterday we discovered if a function or relation was linear. Today we're going to talk about actually working with them and putting them in standard form, all sorts of fun stuff. So first we're going to evaluate and solve. You should like this because it's just plug and chug. Plug a number in, chug away until you have an answer. So we have some Bermuda grass growing. Notice that it tells me X is days. How tall is the sample after 3 days? Well, just take that 3, plug it in for X. So the function, when X is 3, is 5.9 times 3 plus 3.25. So I'm going to multiply 5.9 times 3. That should give me 17.7. Okay. And now I think I'll just add those together, and that's going to give me 20.95. Now, it does tell me f of x is the total height in inches, so that means my label should be inches. So after 3 days, the height is 20.95. Okay. If the Bermuda grass is 50.45 inches tall, how many days has it been since it was last cut? Inches is like the y, it's the answer, right? So that means this time I'm going to be plugging it in on the left. 50.45, equals 5.9 times x, 3.25. And now solve for that. So the first thing I'll do is I'll get rid of the 3.25. And that cancels. So let's try, what is that, 47. Oops. And now to continue my journey getting x by itself, I think we should divide. What do you think? Okay, and it looks like that's going to be 8. 8 what? 8 days since the grass has been last cut. Oh, a thinking question. Is it reasonable to think that this rate of growth can be maintained for long periods of time? And I think the answer is going to be no, because eventually the weight of the grass will kill its growth. Grass doesn't continue to grow forever. It gets to a certain height, and there it's done. Alright, so we're going to rewrite this in standard form. Basically, we're looking for y equals, oh no, I'm sorry, that's slope-intercept form. Got ahead of myself. What we're going to be looking for today is ax plus by equals c. A, b, and c need to be integers. Okay, no decimals, no fractions. We are going to rewrite it so that a isn't negative, but we don't care if the others are negative, and we can't divide them by anything else. So the first thing I would do is work to get, by the way, a, b, and c are going to be numbers, if I didn't say that. So the first thing I'm going to do is get x and y on the left. So I'm going to subtract 4x. And again, the way I'm going to write this is always with the x first, then the y, and it's going to equal a number. And again, one of the rules is I don't like to see the first one to be negative. But the good news is, if you just simply multiply everything by a -1, that will switch all your signs. Negative times negative makes a positive 4x, negative 2y, equaling a negative 5. There it is. 3b is pretty close, so I'm just going to get rid of the 9, move it to the other side. And so far it seems okay, but do you notice that 3, 6, 9, I can simplify that. I can divide all of those by 3, right? So divide by 3, and what that now gives me is x minus 2y equaling 3, and notice that none of those numbers are divisible by any other number. They're all simplified. We can graph using this form of the equation. So basically what you're going to do is plug in 0 for x and then 0 for y. So if I do that, I have 2 times 0 minus 3y plus 8 equals 0. And the other one's going to be 2x minus 3 times 0. Notice that I just plugged in 0 for x on one of them and 0 for y on the other. Those are actually going to cancel. And this should be pretty easy to, oops, that was supposed to be a plus 8 there, wasn't it? So that I can subtract. Y equals a positive 8/3. Since x was 0 when I plugged that in, I need to have a 0 in for the x, and then that's just going to be 8/3. 8/3 is the same as 2 2/3. So that point is going to be approximately right there. So then, if I continue plugging in this 0 over here, then I'm going to subtract 8 from both sides. Oops, that should be a negative 8. And x equals negative 4. So this point is negative 4, 0. 1, 2, 3, 4, and 0. That's 2 points. You only need 2 points to make a line, right? And there you go. All right. That should be all for today. Thank you.